Good evening, everyone, and welcome to our next live session on TCS NQT problem solving. So, just to recall, this is probably the eighth of our session that we have that we're taking live on YouTube to ensure that we give you not only the programs, the questions that are often expected in the live session, we will also be able to look at your queries, your texts in the live chat, and we will be able to answer the same as well. So without any delay, let's quickly go ahead. And before we continue, I just want to put a disclaimer that, as always, this entire um, content is an IP of Quant Masters. So if you do find this anywhere else, please do let us know, and that would be of huge help as usual. So let's quickly move ahead over to today's program. So here's the first thing that we need to know to begin with. Before we start this, we have already gone through a set of MCQs. We have gone through so many MCQs already over the last couple of sessions, and we have gone through one program as well. In today's session, we're going to go through a new program, a different kind of program, which has a very unique solution, which is only known if you know the basics of C well. Whole idea. Only if you know the basics of C well, you will be able to understand this solution. So let's take a look at this and let's try to understand what exactly is the question which requires basics of C and not advanced concepts like algorithms and everything. Here's the simple question. You are given an input array. Simple logic. You will be given an input array. This input array will consist of odd number of elements. That means it can consist of something like 3, 5, 7, 11, any odd number of elements it will consist of. And the thing about this odd number of elements, the peculiar thing about this is as follows. I'll repeat, only one element is repeated odd number of times. All the other elements are repeated even number of times. Your job or your task is to find out which element is repeated odd number of times. That's it. That's all there is. Nothing else. This is the whole question that you have. Sounds simple, right? There's an input array. It has an odd number of elements. The condition is, let's consider an input array with an odd number of elements here. Let's consider this. So I'll have this particular input array. Let's say, for instance, it has, let's say, an odd number of elements. I'll just take, let's say, something like 7 elements. So I'll take 0, 1, 2, 3, 4, 5, and 6. So indices 0 to 6, basically we have 7 elements in total. Now, in this case of 7 elements, all that we need to know, all that we need to go through here is just this. There are elements like 10, 20, 10, 20, 30, 40, and 40. Now, the condition in this array is all elements are repeated even times. 40 is repeated twice. Similarly, 20 is repeated twice. 10 is repeated twice. However, 30 is repeated odd number of times. Only one element in the array will be repeated odd number of times. The rest will be repeated even number of times. Your task is to find out which is that element that is repeated odd number of times. That's all. So let's try to figure this solution. Let's try to figure out a solution for this problem. It's a very simple and easy problem. Way too simple and easy. First thing we will do, as always, is try the brute force method. Try the simple method. If I want to find out which element is repeated odd number of times, when I say odd, it could be repeated one time, It could be repeated 3 times, it could be repeated 5 times, 7 times, could be repeated any number of times. That's the solution. That's the idea. So there are multiple ways for you to figure this out. I'll give you one simple solution, one easy and simple solution that we generally think of. So if you meanwhile think of a different solution in your mind, you can put it in the live chat and I will ensure to go through that. If that is the best solution possible, then congrats, you're doing amazingly well for preparations. If it is not, I'll tell you why it is not and how can we improve as well. So you guys can feel free to do that within live chat. So let's take a look at this very quickly here and try the following scenario. So here's all that I'm gonna do. I have this huge array of elements. Simple logic. I need to check from the first element if each element is available even or odd times. I'll take 10. How many times is 10 available? 1, 2, only twice. I have to go through the entire array. For the first element, I have to go through the entire array to check if it is available even or odd times. Then I have to take second element. I have to go through the entire array to search 20. Then I'll take third element. I have to go through entire array to search 10 again. Then I have to take the fourth element. I have to go through entire array to search. So in other words, each time I take an element, if my element is 10, if I am initially at index 0, I want to see whether the element at index 0 is appearing even or odd times. So all that I'm going to do here is, for the element at index 0, I will compare. Is element at index 1 equal to this? If so, increase count to 2. Initially count will be 1, indicating that the element exists once. Since it's already in array of 0, I can say the element exists once. So all that I'm doing here is a very simple logic. That is, I'm just checking if whatever is in array of 0, is it there in array of 1? If so, increase the count. Is it there in array of 2? If so, increase the count. Is it there in array of 3? If so, increase the count. If it's not there, don't increase the count, just move on to the next element. This is the logic. So here it's available in, let's start from 0. Since it is 0, we're going to check if it is available in array of 1. Yes, so we'll increase the count. Then we'll check if it is available in array of 2. If it is available in array of 1, no. Array of 1 does not have 10. So we will not increase the count. We'll check in array of 2. It is there. So we'll increase the count to 2. Then we'll check in 3, 4, 5 and 6. It's not available in any other index. So we can say the element appears 2 times. So that is not the element that appears odd number of times. Since that is not the element that appears odd number of times, the next thing I have to do is go for index 1. Does the element in index 1 appear odd number of times? To do this, I'm going to do the same thing. Whatever is in array of 1, does it exist in array of 0? No. Does it exist in array of 1? Yes. Since it exists in array of 1, you can say it exists one time. Initially. Does it exist in array of 2? No. Does it exist in array of 3? Yes. So say that it exists 2 times. Does it exist in array of 4? No. In 5? No. In 6? No. So I can say it only exists 2 times. This is how you can, in short and in simple, figure out how many times an element basically exists in an array like this. That's all. So with this idea, we're going to use the exact same logic here. This is our brute force method. This is not the most efficient method. If you find out a better method, if you find out the most efficient method by yourself, please do let me know. I'll be happy to take up the same as well. Alright, so let's take this scenario. I'm going to start with this case. First scenario. In our case, I'm going to start with, let's say, for instance, int. Again, please remember, just as we learned in our previous session, you will not be given main function to modify. You will be given a separate function. That separate function is supposed to return which element is repeated odd number of times. It's just supposed to return. So I will write int find odd of a function. In your interview, you are supposed to only write this function. The rest of it will already be given. So the rest of it will be an array of 7 like this. I'll take the same example I have here. 10, 20, 10, 20, 30, 40 and 40. So I'll take 10, 20, 10, 20, 30, 40, and 40. We know 30 exists odd number of times. It is compulsory that one number always exists odd number of times. It could be 1 time, 3 time, 5 time, anything. So I'm just gonna call find odd and I'm gonna send array and its length. This is what I'm gonna do. And whatever is the result of that function, which is the integer, I will print here just so that you can see what is the result on the screen as well, which is what we are supposed to return from find odd function. And this part will also be given. We are reading an array and we are reading an integer, and both will be given. And you will be asked to write your code here. That's what you will be asked. So the rest part will be already available. You will only be asked to write your code within this particular function over here. That is what will happen. So let's take a look at this. Before we begin our logic, let's start with this. In our scenario, I need to go through every single element to find out whether that is the element that is repeated odd number of times or not. I need to literally go through every single element to do that. So what I will do here is, I'll take an integer I, I'll use for I equals 0, I less than n, I plus plus, which means that I iterates for each index of the array. In short, for each index of the array. If your array has 7 elements exactly, I will go from the value 0 to 6, because we are using it here basically I less than n. Since we are basically using I less than n, you can simply say that it repeats for all the elements in the array, in short. So once we repeat for each element in the array, all that we are going to do here is use another for loop, because we need to check in our scenario, if I is 0, we need to check if the element in array of 0 exists how many times exactly. So for that purpose, I'm going to initially consider that the element in index 0 exists 0 times. So for j equals 0, j less than n, j plus plus. The inner loop is where we will compare array of I with each element of the array. That's basically what we'll do. So compare array of I with each element of the array. Since we need to compare it with each element of the array, I have to use an inner loop which again repeats n times. So all that I'm going to do here is, if array of I is equal to array of j. Remember, I is the outer loop. Since I is the outer loop, it remains constant. So I will be 0. So throughout this inner loop, I will be 0. But j value keeps changing because j is the inner loop. J changes from, in this case, 0 to 6. So here I will be 0, j will be 0, 1, 2, 3, 4, 5 and 6. J will change to all values. In this case, all that we are doing here is creating a count variable which is initially 0, and we're just checking if array of I and array of j are equal, increase count by 1. Then array of 0 and array of 1 not equal, array of 0 and array of 2 equal, so increase count by 2. So we keep repeating this. At the end of this logic, at the end of this entire comparison, if the count value is odd, that is, here you can say if count mod 2 is equal to is not equal to 0, that is, it is odd. If it's equal to 0, we know it's even. If it is odd, we just return that array of I, because that is the one element which is repeated odd number of times. So this is our simple logic to solve this. So I need to declare one more variable j. Let's do that. And I'll also declare count here and just remove this declaration line. Let's see if it works. So if you take a look at this, it says 7. Is that right? Is that really right? It's saying return array of I. It's saying 7 is repeated. 7 is repeated so many number of times. So find odd function is supposed to return a number. The number it is returning is 7. Something went wrong, right? Our logic is supposed to be right. Think about it. Think about it so far. Our logic is supposed to be right. We sent 7 elements. We received the array here. And we received the number integer n also here. So you may expect these kind of things. That's why we are basically working on examples like this. And we still haven't started with the most efficient method. Please note that. So we have three variables, I, j, and count. And we're just going through this where we are going through every element. We are going through each element and finding out how many times it exists throughout and keeping a count. The problem here is, are we increasing the count anywhere? Take a look at this. If array of I and array of j are equal, we're supposed to perform an operation that is count plus plus, right? So in short, if I want to find how many times 10 is present, that is, if I want to find how many times array of 0 is present throughout my array, I have to compare, is array of 0 equal to array of 0, equal to array of 1, equal to array of 2, equal to array of 3, 4, 5, and 6. Each time I compare, I need to increase a variable called count, which we are not doing here. So that's exactly what is missing in our code. So if you take a look at this, you just need to use count plus plus, and now you can give this a try. You'll be able to see that it gives you some particular value which it thinks, which the code thinks is repeated odd times. So now is the logic correct? No, because one more mistake. We are using semicolon at the end of if condition, which again should not be there. Such simple mistakes can happen often. It's pretty good to check such cases. Now if you take a look at this, 30 is repeated odd times, you're able to find it. If I repeat 33 times as well, you will still be able to find that 30 is repeated odd times, you'll get the value. Is that right now? No. We are losing in test cases again. We are literally unable to solve for multiple test cases. Something went wrong this time. 30 is available 3 times. Since 30 is available 3 times, it is available odd number of times. Since 30 is available odd number of times, it's supposed to say 30 is available odd number of times. But here 10 is also available odd number of times. Look at the question. It says only one element is repeated odd number of times. So don't even think of such questions. If you're repeating 30 multiple times to try a test case, make sure 10 is repeated twice, because only one number can appear odd number of times in this program. Now you can get it as 30. Now this particular solution is your brute force technique, is your simple brute force technique. I'm just gonna paste it in here, just copy the same code which we will be sharing by the end of the session, so that you can access this code later on as well. You can access the same code here later on as well if you guys would like. I'll just title this, if I can find where to title this. Okay, here it is. The title, I'll just put it up as Quant Masters NQT. That is the date 18/12/2021. That's it. So I'll just provide this. It'll be public. It'll never expire. You guys will be able to access this. So this logic so far is your brute force technique. But we don't want brute force technique. We want the most efficient technique, because we want to clear NQT. We don't want brute force technique which may give us a time limit exceeded error. We don't want this error. This error means that our program will not be selected at all. This error means that our program will not be considered as a program that has been successfully executed at all. So to avoid this, again, I'll explain why this may give you time limit exceeded error. Take a look at this. How many times does the outer for loop execute here? Outer for loop repeats n times. How many times does the inner for loop repeat? Also n times. So in worst case scenario, your comparison will be done n square times in the worst case scenario. That's too much. If you want to make sure you get through interview in a better time, that's too much. We don't want to do that. So what do you think we can do otherwise? Let's see if any one of you can figure out a logic. Let's see if any one of you can think of a solution which can possibly help. If not, then that's completely fine. I'll give you a couple of solutions from my end which can help solve this. First solution is keep a track of all the elements. That is, if keep a track of how many elements you have and keep their count. To keep their count, you need to create another array. That's also very complicated. So there's a very simple and easy logic here which can be done in big O of 1. Just so that everybody knows, if somebody is from a different branch here, just remember, We use big O to identify time complexity. We use big O to particularly identify worst time complexity. So whenever you talk about time complexity, that is how long will your program take. In our case scenario, our program may take n square number of operations. Our program here may be required to perform n square number of times, because remember this particular statement may be required to run exactly n square times throughout. So if you want to avoid your program running a total of n squared amount of times, all that you need to do basically here is just go through your program and find a method which can run it in less than n square steps. So I will show you a very simple logic for this, which can run in possibly n steps itself. So when it runs in n steps, you get the burst time complexity as big O of n. And the solution to this is in something called basics of C language, which is often underlooked or overlooked, you can say, which is often not looked at by programmers, which is often not learned and studied by programmers. That is what we basically call as simple operators in C, which we particularly point as bitwise operators. If you think back, what are the bitwise operators we have? We have bitwise AND, bitwise OR, bitwise XOR, bitwise negation, left shift, and right shift. So let me explain and tell you why bitwise operators help you here. I'll just comment this and I'll just write a different code. I'm just gonna write here printf %d/n, comma 5 and 7. It's a bitwise operator. So when you perform 5 and 7, since it is bitwise operators, you need to take bit number of 5 and binary number of 7 and perform the operation. Let's take binary value of 5. If you take the binary operations like 8, 4, 2, 1 here, 5 is 4 plus 1, the rest are zeros. You can basically consider 5 as 101. So I take 5 as 101. And I have 7. 7 is considered as, again, let's take the same scenario, 8, 4, 2, 1. Again, if you want to take larger numbers, just keep adding 2 powers, like 16, 24, whatever you want. 16, 32, whatever you want. Right. So here 4 plus 2 plus 1 gives us 7. So I can say it is 101 and 111. This is bitwise AND. So you're taking 101, 111 and you're performing bitwise AND operation between them. When you perform bitwise AND operation between them, remember, how does AND operation work? As it says, both inputs must be true for output to be true. Both inputs must be true for the output to be true. So let's take both inputs here. So we got two inputs, 1 and 1. Are both inputs true? In bits, 1 is considered as true, 0 is considered as false. So that's one little thing we need to just know and remember. Alright. So both inputs must be considered to be true for the output to be considered as true. So if you take a look at this, 1 and 1, both are true. So output is true. As it says AND, since AND is there, both must be true. So here you take 0 and 1, both are not true, output is 0. 1 and 1, both are true, output is 1. Coincidentally, the output of 5 and 7 is one of the input, that is 5. It will not always be the case like this. So here we are supposed to get 5 as the output. Again, you may be wondering, so instead of going through our program, why are you explaining bitwise operators? You will get to realize very soon that this will give you the most efficient method to solve this particular program. So 5 and 7 we get 5. What if I try 5 or 7 on the other hand? Or let's take 5 or 6 instead. So when you take 5 or 6, can you guess and let me know before I get to quickly execute in live chat? Can you guys let me know? Let's see if you can. I'll be very happy to read the answers out or at least see them. So 5, as we know, if I take 8, 4, 2, 1, 5 is 101, 4 plus 1, so I'll take 101 as 5. 6 is 4 plus 2, so I'll take it as 110, so I'll take 110. Now when I perform OR operation, any one of them should be true. In this case, 1 or 0, one of them is true. 0 or 1, one of them is true. 1 or 1, both of them are true. Since you're not adding them to carry and everything, it's just, you're just figuring out whether they are true or false. If any one of the input is true, output should be true. If both inputs are false, that is, if both inputs are 0, only then output is 0. That's how we figure it out. So you get the output as 7. That's also something easy. We can do this very, very quickly in an easy way. However, the bitwise operators we require, the bitwise operators that's important for us is XOR. It's called exclusive OR. So just to point out, remember, see documentation, Microsoft Bitwise. I'll just search for this. You should be able to get the official documentation link here if you just search this, because official documentation is available within documents.microsoft.com. So here you take a look at this. There's this particular exclusive OR operator which compares each bit of its first operand and to the corresponding bit of the second operand. The logic is, if one bit is 0 and the other bit is 1, that is, if you have something like this, let's say for instance 1 0 or 0 and 1, that is, if the bits are different, in other words, the corresponding result bit is set to 1. Observe this. If one bit is 0 and the other bit is 1, the corresponding result bit is set to 1. So here corresponding result is 1. If both inputs are different, output is 1. What if both inputs are same? What if both inputs are 0 or both inputs are 1? What happens in that case? If you take a look at this, it says otherwise the corresponding bit result is set to 0, which means if both inputs are same, result will be 0. This gives me an idea. This gives me a very, very good idea. Think of this. If I perform 5 XOR 5, observe this. I'll give you a very simple example to understand this. If I perform 5 XOR 5, how many times do we have 5 here? 2 times. That's an even number. Since I have 5 XOR 5, 5 is 101. 5 is again 101. When I perform XOR, what will be the result? Let's take a look at this. The idea for bitwise exclusive OR is that if one bit is 0 and the other bit is 1, result is 1. Otherwise means both bits are 0 or both bits are 1, result is 0. Which means in this case, here both corresponding bits are 1, result is 0. Both corresponding bits are 0, result is 0. Both corresponding bits are 1, again result is 0. So if a number appears twice, result will be 0. What if the number appears odd number of times? Let's even give that a check. What if the number appears 3 times? Take this scenario. Let me perform 5 or 5 or 5. When you perform this, it must execute left to right. It must execute from left to right, of course. So let's start left to right. Like this. First, let's perform 5 XOR 5. 5 XOR 5 is 101 XOR 101. 101 XOR 101. Since there is even number of times it is occurring, your result is 101 101. All bits are same, so output is 0. So output will be 0. Is that correct? Think back. Take a look at this. One bit is 0, other bit is 1, only then it is 1. Otherwise, the result is 0. Now here, in this case, take a look at the next number. When you perform XOR with the result of this with XOR of the next number, previous result is 0, 0, 0. The next number is 5. 5 is 101 again. When you perform XOR with this, are the bits same? No. Are the bits same? Yes. Are the bits same? No. So result is 1. So in that case, when the number appears odd number of times, its XOR result is the same as the number. That's the logic. If you are finding it difficult, let me just explain it once more. Take a scenario. If you take 5 XOR 5, the result is 0. If you take, however, 5 XOR 5 XOR 5, the result is 1. To prove this, let me just run this. I'm going to take 5 XOR 5. Let me run this. You'll get to see result is 0. Let me perform XOR odd number of times. Now you get the result as 5. Again, let me do once more, even times. Your result is back to 0. Let me do once more, odd number of times. Your result is 5 again. So what I am trying to say here is, if a number appears even number of times, you can perform XOR between them and its result is 0. If a number appears odd number of times, you can perform XOR between them and the result will be the same as the original number. This gives me an idea. I'm going to take my original array, I'm going to perform XOR between all those numbers to see whether I can find the odd number or the number that repeats odd times. Because if you observe this, here you have 10 XOR 10. 10 XOR 10 will become 0. We know that. Here you have 20 XOR 20, that also becomes 0. You have 40 XOR 40, that also becomes 0. But 30 is separate. It's repeated odd number of times. So the result will be 30. You can directly get the number of times an element is odd. Which element is appearing odd number of times. This is the simple logic to do that. So all I'm going to do in this function is, instead of using this inner for loop and this count variable, I will remove all this code. I'm just going to create something called result equals 0 initially. All I'm going to do here is, for each element, we need to perform XOR operation. If I'm able to perform XOR operation for each element, my logic is done. I literally don't have to worry about the rest of the situation. I literally don't have to worry about the rest of it. So this can be done in a very, very simple logic. So I initially have result is 0. So all I'm going to do here is just take result equals result XOR array of I. That's all. That's it. And I will return result. For everyone who's confused with this, think of this. I'll give you a very, very simple example to understand this very clearly. I'm going to take a very small example here so that we can easily solve this. I'll take 5, 5, 3, 3, and 5. There are 5 elements. Index 0, 1, 2, 3, and 4. So initially the result value is 0. So the first thing I'm going to do is, for each element, I will perform XOR with result. First element is 5. 5 is 101. Let us perform XOR with 0. When I perform XOR with 0, element is different, element is same, element is different. When the corresponding bits are different, output is 1. When the corresponding bits are same, output is 0. So I will get 5. So result will be updated with 5 when I perform XOR with the first number. Now this result, I will perform XOR with the second number. 5 XOR 5. We already know the result. For our easier understanding, it is 101 XOR 101. Since all the corresponding bits are same, your result is 0. So you can say, since the result is 0, basically, result is updated now to 0. Because whatever is result XOR the number, that is array of I, we are storing it back in result. So let's go for the next index. The next index is 3. So now I'm performing this 0 XOR 3. So 3 is 0, 1, 1. Result is 0. When you perform 0 XOR 3, you will get, again, input is different, input is same. When input is same, it is 0. When input is different, it is 1. So you get 0, 1, 1, 3 itself. So now you can update this to 3. Once that is done, let's go for the next one. We got 3 again. So what is 3 XOR 3? 3 XOR 3, you will have 3 is 0, 1, 1. Again 0, 1, 1. Result is all same. So your output will be 0, 0, 0 here. So you can say when you perform this, it becomes back to 0. Now result is 0. You are performing XOR with the last element. The last element is 5. So let's perform 0 XOR 5. Now result is, corresponding bits are different in these cases. Result is 1. Corresponding bits are same. Result is 0. You get 1, 0, 1, which is 5. Is 5 appearing odd number of times? Absolutely yes. So you can directly figure that out with just one for loop, nothing else. You don't even need this bracket since there's a single statement. You can run this directly and you will be able to solve this. So I have made one mistake. I'm supposed to use result here. I've used the wrong string or wrong variable name. Let's take a look at this. Now if you observe this, you can see the element that is repeated odd number of times. We can even try repeating it more number of times. You can still see that you can get the same output that the element repeats odd number of times. So we reduced an operation, a statement which is executing n square times to only n times now, from n square times. And we also reduced a few variables used as well, like j. So this is our most efficient solution for this program. So this is how you can find possible solutions. So what I would suggest is don't forget basics like this. So the reason why I'm taking this particular example for everyone to please kindly observe and note here is because such programs are commonly asked, especially in TCS NQT, because you are given 45 minutes to solve. I will repeat, you are given 45 minutes to solve two programs. So when you're given 45 minutes to solve two programs, one program can be very quickly solved within around 20 minutes. So in such case, complicated questions will not be asked. Such easy questions will be asked rather. So please note and remember, such simple questions will be asked where if you know the logic, where if you know the concepts, you should be able to answer them well. So let me just share this here with you for you to access this code later on if you guys would like to. So with this, I hope you found it. I hope everyone's finding these kind of questions simple and easy to answer. We are going through such questions which could be asked when it comes down to TCS NQT, and we are solving it with the most efficient method possible. So you can repeat the same in your interviews. So try to go through such basic logics. Try to go through different tips and tricks like this. If you want to know more about such things, you can always reach out to us. We have special courses to do the same. So with this, we'll end our session here today. We'll catch up again very soon. Until then, keep practicing well. You've got a week more. You've still got enough time to prep up well. So good luck with your preparations. Thank you for joining in.